Hello all, hi. Yesterday I went through the concepts and how we find the distance between two planes, okay? So I promised that today I'll go through a challenging questions involving vectors distance between two planes. Alright, so before we delve into the question, I just want to let you know that there are a few formats for writing the vectors equation of a plane. So yesterday when we were finding the distance between two planes, we were using the R. Okay, let me get my pen out. We were using the R dot N format. Okay, so N is the normal to the plane or the vector that's perpendicular to the plane. So say 2, 1, 2 equals to 3. Okay, so what this means is we have the plane and then the normal to the plane is 2, 1, 2. Okay. All right. There's the second way of writing a vectors equation is we call it the Cartesian form, which is if we replace the R with x, y, z, right? 2, 1, 2 equals to 3. So the Cartesian form of the vectors plane equation will be 2x plus y plus 2z is equals to 3. Okay. All right. So this is the R dot N form. This is the Cartesian form. All right. That is the third format to express equation of a plane. Okay. And that is, we can say this is plane 1 minus 3, 2 plus say lambda of 1, 2, 0 plus mu of 0, 4 minus 2. Okay. So what does this mean? How do we interpret this format of the vectors plane equation? Firstly, this is a point on the plane. Okay, this is a point on the plane. And then this and this, the 1, 2, 0 and 0, 4 minus 2 are the two vectors on the plane, or i.e. they are two vectors parallel, because they're on the plane, so there are two vectors parallel to the plane. Okay. All right, so how do we then convert this form of the vectors equation into the R dot N is equals to the whatever number format, the R dot N format? How do we convert this format into this format of the vectors equation? For this, I have to go through we're going to apply the cross product of vectors in order to do that. So let me explain what the cross product of vectors is. Okay. So vectors or vectors cross product. So if we have vector A cross with vector B, is, the formula is mod A mod B sine theta. Okay, so we have vector A, vector B. The angle between the two vectors is theta. Okay, so, and then this is the n cap. Okay, so what this means is simply, this is the magnitude of the output vector. When you cross two vectors, you get a vector that has this magnitude, means it's the length of the output vector, and this is the direction of the resultant vector, the output. So when you cross two vectors, you get a vector that is perpendicular to A. Okay, let me just use another color here. Okay, you get a vector that is perpendicular to A. Okay, and also perpendicular to B. Okay, also perpendicular to B. So if vector A and vector B are vectors on this screen, imagine it's the vector A and B are on this screen, and when you cross A and B, the resultant vector n would be a vector that comes out of this screen or goes into the screen, because the resultant vector n is perpendicular to A and B, which means it comes out or go into the screen. Okay, so remember, the cross product is called a vectors product because the resultant, the output has a direction, and the direction is perpendicular to the vectors that you're crossing. Okay, perpendicular to A and perpendicular to B. Okay. So once again, if A and B are on this screen, the resultant n comes out of the screen or goes into the screen. Okay, so now I will be and then, okay, what is this cap here? We call this n cap. The cap here, which is this cap, is this signifies a unit, one unit, okay, unit, one unit. Why is it that this n cap has to be a unit vector? Because it means the unit is 1. Because we already have the magnitude, so we need the direction to have only unit 1 so that we don't double count the magnitude. Okay, so mod A is a magnitude, mod B is a magnitude, sine theta is also a magnitude. There's no direction. So this is the length of the resultant vector, and this is the direction, right? This is the direction of the vector, of the resultant vector, which is normal to both A and B. Okay, I reiterate, if A and B are on this screen, n is a vector that comes out of the screen or goes into the screen. Because when you rationalize it this way, right, it's very easy to understand. Okay, all right, then. Okay, so the reason why I'm going through these vectors cross products, because we need to use this to convert the vectors equation of a plane that is in this format. Let me just go back to the vectors equation of a plane in this format. Okay, this is 0. Okay, the vectors equation in this format into the r dot n equals to a number d format. Okay. So earlier, just recap. So what does this mean? This is a point on the plane. Okay, so say 1, -3, 2. And this are just basically two vectors on the plane. Okay, just alright, so let me just draw, say 1, 2, 0, 1, 2, 0, one vector and another vector, say 0, 4, -2. Okay, so 1, 2, 0 and 0, 4, -2. The two vectors on this plane. Okay, so remember, when you cross two vectors on a plane, you get a vector that is normal to the two vectors. When you cross two vectors, you get a vector that is normal to the two vectors. And because these two vectors are on the plane, when you cross these two vectors, you actually get a vector that is normal to, oh, I shouldn't do a highlight. I should change the color. Okay, you get a vector that is normal to the plane. So you see, there you have this normal vector now, right? When you cross, so when you cross 1, 2, 0, and when you cross, okay, 1, 2, 0, and 0, 4, -2. Okay, when you cross this and this, you get a vector that is I will record in a separate video how you cross two vectors, the fastest way to cross two vectors, because in exams your speed is very important. So now I will just give you I'll just write out the answer. In a separate video, I will show you how to cross two vectors in the fastest way in the exams. Okay, so then because this is -4, 2, 4, right, you can put it to the lowest term. You take out the 2, you get -2, 1, 2. Okay, so your direction, the normal to the plane is actually your -2, 1, 2. So remember, vector, you just need a direction, so you can always put it to the lowest form. Okay, reduce it to the lowest form. So this is your, so yeah, I have converted this format into the r dot n format. But what is this number, d? So you remember from yesterday's lesson, right? Any point that is on the plane will satisfy this. So what you simply need to do is, you know that this is a point on the plane, right? So what I'm going to do is, I'm going to, this point, I'm going to put here 1, -3, 2, dot with 2, -2, 1, 2 will be 1 times -2 is -2, -3 times 1 is -3, plus 4. So this gives us -1. Alright, so that means this d number is actually -1. Alright, so it means the r dot n format would simply be r dot -212 is equals to -1. Okay, so this is how we convert this vectors equation of plane format to the R dot n format. Simply using the cross product of two vectors, which is parallel or on the plane. So remember, when we cross two vectors which are on this plane, we get a vector that is normal, which comes out or into the plane, which means we get this normal to the plane. Okay. So now we want to go to the challenging questions involving two planes. Okay, the question is, find, let me go back to this color. Find the equation of the planes with a distance of 9 units from this plane we want to find the equation of the planes with a distance of 9 units from this plane. So this plane was the one that we converted into the R dot n, R dot minus 2, 1, 2 equals to minus 1. In the previous slide, right? We converted this into this R dot n format. Then now we want to find the equation of the planes with a distance of 9 units from this plane. Okay, so I'm going to draw the side view of the plane. So this is the side view of this plane. Okay, and why does it say, why is that planes? Because 9 units from this plane, right? The plane can be on top or below, right? It can be 9 units. It can be 9 cm, 9 meters. Okay, 9 units on top or below this plane in question. Okay, so yesterday I was doing like front to back, right, where you are given the equation of two planes and then you find the distance. Yesterday you were finding this distance here, right? That we call it, you're working from front to back. The question that here is you're working from back to front. You are told that the two planes are 9 units from this, the purple plane are 9 units from this yellow, this plane, and you want to find the vector equation of these two planes. You want to find the vector equation of, okay, just, you want to find the vector equation of this plane and this plane. Okay, so let me just write out this. Okay, so we have, this is the vector equation of this plane. Okay, R dot minus 2, 1, 2 equals minus 1. And the vector equation of this plane is what we want to find, which is, I'm going to write it in terms of this one will be R dot. And remember, because whenever you're asked to find the vector equation of plane, the distance between two planes, right? The two planes must be parallel. Because as I explained yesterday, right? Can you imagine if the two planes are not parallel? Imagine if the plane is like that, right? It doesn't make sense to find the distance between two planes because this distance here is different from this distance, right? So whenever you're asked to find distance between two planes, right, the two planes must be parallel. So for two planes to be parallel, they must share the same normal. All right, so which is why straight away I know that I can use this as the same normal, right? Minus 2, 1, 2. Then that leaves me with this D that I need to find. What is this D? If I can find this D, that means I can answer the question. I can get this equation of the plane 9 units from this plane, right? From this center plane. Okay, so yesterday I gave you the magical formula, all right, which is let me just write this here first so I get more space to work out the question here. So I'm going to write this equation here, minus 2, 1, 2 equals to minus 1. Okay, so I can erase this and I get more space here. Alright, so let's use the D1 minus D2 to solve. We need to form an equation with the D1 minus D2. Okay, let me use green. Oh, it's okay, let me use the pink. Alright, so oops. We know that D1 minus D2 D1 minus D2 is the distance between two planes. Okay? If you want to get a recap of how I arrived at D1 minus D2, you can refer to the video called Vectors Distance Between Two Planes. Okay, so D1 minus D2 is 9. Okay, because D1 minus D2 is the distance between the two planes, which is 9. All right, so D1 would be minus 1 over mod of 2, 1, 2. Okay, you can also refer back to the same video called Vectors Distance Between Two Planes to see why is it D1 is not negative 1 over 2, 1, 2, and D2 would be D over mod of 2, 1, 2. Okay, so this is equals to 9. Let me use a different color because this color is a bit striking. Okay, then so we have minus 1 over mod of 2, 1, 2 is actually 2 square, root of 2 square plus 1 square plus 2 square, which actually is root of 9, which is 3. Okay, so I'm just going to straight away write 3 here. Minus 1 over 3, then minus D over 3 is equals to 9. Okay, let me erase. Okay, I just write this onto the next screen. Okay, which is minus 1/3 minus D over 3 is equals to 9. Alright, now I'm going to remove the mod. What does mod mean? So if this inside here, right, this minus 1 over 3 minus 1/3, right, over D over 3 is equals to negative 9, when I mod this, it becomes a plus 9. correct? Because negative 9, when I mod, I only need a magnitude becomes plus 9. So when we open the mod, this is negative 9. So whenever you have mod, right, you will have two answers. So this is negative 9, or you open up the mod, right, or this is 9. Because when this is 9, mod of this is 9. So when this is negative 9, the mod of this is also 9. So this is how you open up the mod. Okay. Then I'm going to use minus 9 times 3, which is minus 27, or 9 times 3 is 27. Okay, so I'm going to move. So basically 1 plus d is equals to 27. Okay. And d is equals to 27 minus 1 is 26. Or this one is 1 plus d is minus 27. Right? So d is 9 times 3. This is 27. Okay, so this is minus 27 plus, or minus 27 minus 1. So this is minus 28. Okay, minus 27 minus 1, minus 28. So you have two answers for D, which makes sense because remember the previous slide, you have two planes. One is here, right? And another one is, you are supposed to have two answers, this and this. So that means this plane, remember your answers are 26 and minus 28, right? So this D here is 26, okay? And this is R dot minus 212 equals to negative 28. Okay, so this means that the origin is actually between the 26 and 20, because one is this is a negative signage, which means it's below the origin. This lower plane is below the origin, whereas the upper plane is above the origin. Okay. Yeah, so this is how you solve a challenging question where you are given the distance between the two planes and you have to work out the equation of the planes. So that's why this d1 minus d2 is a very powerful formula, because once you are able to form an equation, you will be able to remove the mod and then you'll get two answers. Okay, and then you get so basically this is your first answer. This is the first equation of plane. This is the equation of the two planes, which are 9 units from this middle plane. Okay, I will share with you an even more challenging question in the next video. So do subscribe to my channel. Bye.